Hello, I'm Gordon Now, aka World of Depth, and today I'd like to explore with you the world of 3D catadioptric stereos. So first off, do we mean catadioptric as in cats with two eyes? Now, these are 2D stock photos, but it does so happen that they can be converted into catadioptric stereos like this. So how does that work? Well, when your line of sight is almost parallel to a reflective surface, what you see in the reflection and what you see directly is quite similar. If you unreflect the former, you'll see that these images have elements that are horizontally offset. In other words, they exhibit parallax, and hence can be made into a 3D stereo pair. This is what's happening. The reflection gives you a view of your subject from a slightly different angle. It's equivalent to walking a very short distance around your subject and taking a second shot from here. In other words, this type of motion, which can yield a stereo pair like this. So that's how it works with the subject right at the mirror and the camera farther away. But what if we swap positions of the subject and the camera, like this? This is the subject's view. If you do this while carefully positioning the mirror and your subject, say a flower, you might capture a photo like this, where about half your view is the mirror reflection. And if we apply the same basic method as before, unreflecting one half, plus a little processing, which I'll discuss later, then the resulting stereo pair can work very nicely in 3D. Here's how it works now. At left is a camera with its left half view shown in blue and right half in yellow. When you bring the mirror up to the camera lens, as shown at right, it reflects the blue half towards the right while leaving the yellow untouched. The area in green is the region for which the camera gets two different views, the yellow directly and the blue reflected. Hence you can create stereo pair views of things within the green region. This is one example of what is called a catadioptric system, a term coined by Hecht and Zajac in 1974, referring to a combination of reflection, in this case the mirror, and refraction, in this case the camera lens. But such systems in stereography were written about as early as 1903 by Theodore Brown, who described his invention called the stereoscopic transmitter, which used two connected mirrors to converge upon a subject. Of course, there are many other arrangements possible for catadioptric stereos using any number and shape of mirrors and lenses. See the links in the description below for other examples. So, why take catadioptric stereos? For starters, if you're like me and wind up shooting most often with a camera phone or similar, you know that the sequential stereo method, aka cha-cha, has certain problems and limitations. But when you shoot with a mirror, you capture both halves of a stereo pair simultaneously, which enables you to take stereos of scenes with moving objects, wind, moving water, changing lighting, etc. In addition, this method is well suited for close-up, almost macro stereos, something for which even 3D cameras often need special attachments. Finally, if you think of the mirror as a kind of special attachment, then it's one of the easiest and cheapest upgrades you can get for your 3D photography. I'll add that the ability to take close-up stereos of moving subjects is perfect for things like insect photography. For example, here are some catadioptric stereos that would have been impossible to take sequentially. So there you have why take catadioptric stereos. Now let's discuss how. I'll cover front surface mirrors, mirror and camera positioning, and image processing in post. First, mirrors. Although you can start with any handheld mirror, you'll get the best results with a front surface, aka first surface, mirror. If we look closely, we can see the differences. Notice that with the ordinary mirror at left, there is a small gap between the figure and its reflection. It appears to be floating. There is no such gap with the front surface mirror. If we zoom in even more, in the ordinary mirror, you can also see a faint second reflection, such as near the figure's hand and beneath its feet, which is not present in the front surface mirror. This is because most ordinary mirrors have the substrate, usually glass or acrylic, atop the thin layer of metal that actually does the reflecting. Often the bottom side of this metal is painted. This protects both sides of the metal from scratches and smudges, but the surface of the substrate itself produces a faint second reflection. It also accounts for the gap we saw. These issues are avoided with the front surface mirror, where the reflective layer is on top. Optical instruments use these mirrors, which you can find in small sizes fairly cheaply on eBay. Of course, beware that their metal surfaces can easily be scratched. Next, positioning. Once you have a mirror, front surface or not, it takes a little practice to use correctly. You want to bring it up to the camera lens, holding it vertically, and move the mirror edge just out of view. Then tilt the far edge of the mirror inward until roughly half your view is the reflection, moving as needed to center your subject. It does take some trial and error, and the exact position and angle will depend on your mirror and your camera. Another positioning consideration is the distance to your subject. This method I'm showing is generally best suited for close-up, almost macro stereos, around 1 to 2 mirror lengths away. If you prefer less depth or take stereos for large display, of course you can shoot farther away. For more depth, you would need a larger mirror held farther from the camera. On to processing. Now that you have your raw catadioptric capture, your first step should be the adjustments you would normally make with any photo, like exposure, colors, etc. These are best done while the two halves are still joined. Second, if needed, tilt the picture to make the mirror edge perfectly vertical. Then separate the left and right images along that line and flip the left horizontally. By the way, you can of course do this entire process with the mirror on the right, changing accordingly. Now we have our basic stereo pair. But if you view it in 3D, and I'll show it just briefly here, you'll see there are minor issues with it. The most notable is what's called keystoning or yaw distortion. Remember when we said that the reflected view indicated here is equivalent to walking around the subject and taking a second picture? Well, when you rotate around an object, or when an object itself rotates relative to you, its appearance distorts in a trapezoidal fashion, with one side becoming stretched and the other compressed. Though this example is extreme, even slight rotation in this manner, like what we get from the mirror reflection, will introduce some amount of this trapezoidal distortion. Another issue is distance from the subject. Notice here that the path of the reflected view, bouncing off the mirror, is slightly longer in total than the path of the direct view. This makes the reflected image appear slightly smaller than the direct. It can also make the focus slightly different. Fortunately, sharpening and resizing images is pretty easy. However, in order to correct the trapezoidal keystoning precisely, technically you need to undistort using 4 manual control points at the corners of the trapezoid, using a program like ImageMagick or Photoshop. Fortunately, Masaji Suto's great program Stereo Photo Maker can very conveniently correct most keystoning, as well as match sizes, with its auto-align function. Here is the result of that auto-alignment, plus a little sharpening of the reflected image, and in 3D. Another optional step is to adjust the 3D placement of the left and right edges, for example, like this. For more information on cropping and edge placement, see my blog tutorial linked below. So there you have it, the why and how of catadioptric stereos. With any camera, a small mirror, and some practice, you can take close-up stereos of even moving objects. I encourage all 3D fans to try this. For more 3D from yours truly, subscribe to my channel on YouTube called World of Depth. It helps if you search with the quotes, and on Instagram as World of Depth. Good luck, have fun, and remember, everything is better in 3D.